Hello, my good students. Welcome to the Marshable Math Show. Today we're going to do some basic algebra. So get your pencil, paper, calculator. No, what's the song? Pencil, paper, calculator. And we're going to do three kinds of equations here. So let me share my screen with you. Oops, I need to drag my iPad across. Here we go. Okay, so basic algebra. Algebra is mathematics of unknown numbers. What we're going to be doing is we're going to be using rules of algebra to have the system tell us for certain what the answer is. Algebra is not figuring out what a number might be and then plugging it in and seeing if it works. This is not guess and check. If you do the algebra rightly and you show the method steps, step by step by step, because the pencil is the tool of your mind, the algebra will tell you what the answer is and you know it's the answer for certain. So let's start with number one. I'm going to say negative 7x, x is the unknown number, plus 31 is equal to negative 25. So now here's how I would solve this. First of all, I got to copy it down right. Secondly, I'm going to look. Okay, find your equal sign. There it is. Then look to the right, like you're crossing the street, and then the left. Here's the variable. What's going on with the variable? It's being multiplied by negative 7. That does not mean x subtract 7. It means negative 7 times x, and then plus 31. And then the answer here is negative 25. So what this is saying is that negative 7 times some number, then plus 31 has to equal negative 25. We need to find out what that number is. We do that by doing inverse operations. Basically, we run the mathematics backwards. Now, one of the rules for algebra is whatever you do to one side of the equation, you must do to the entire other side. So if you say that real fast as a word, it's wadatsui wadamanabatas. But what that means is the values can change so long as we keep them equal to each other. So the first thing I want to do here is I want to do the simple thing first. Which is simpler, adding 31 or multiplying by 7? Adding 31 is the simpler operation. So I'm going to reverse that by subtracting 31 from both sides. The opposite of addition is subtraction. So over here on the left side of equals, and if you need to, you can draw a little dashed line here to show you right and left side. We always work equations vertically down the page, never horizontally. I'm going to subtract 31 from the left-hand side of the equation, but in order to maintain equality, I have to subtract 31 from the right side, so minus 31. And I'm going to bring my equal sign straight down now. Straight down. The right-hand side is the simplest thing to simplify. That's going to be negative 25 minus 31 more. What is that? Negative 56? I think that's negative 56. When the signs are the same, you add the numbers and you keep the common sign. Now, what is plus 31 minus 31? Well, those cancel. That was the whole point of doing that. We get those to equal 0. So these drop out. And what I have remaining on the left-hand side is just negative 7 times x. So now I have an equivalent equation. An equivalent equation is an equation that you get from doing allowable transformations, which is what we just did. It has the same solution as the original. So now this is negative 7 times x equals 56. Don't abandon the algebra and just use your imagination now. Finish the job algebraically. How do I reverse multiply by negative 7? What's the inverse of multiply? Well, that would be division. So I'm going to divide using a horizontal fraction bar. Never use that 5th grade symbol. No, never going back to 5th grade. It's good news and bad news. So I'm going to divide both sides by negative 7. Negative 7 on the left, negative 7 on the right. Now, drop my equal sign again, straight down. Negative 56 divided by negative 7. Well, I don't know. You use your calculator. Or do you really need your calculator for that? Like, I don't know. Maybe 6 divided by 7. Oh, it's 8. And it's positive 8 because a negative divided by a negative is a positive. So now on the left-hand side, notice that a negative divided by a negative is a positive, so those cancel. And then 7 divided by 7 is equal to 1. And that's what we want. We want 1x. What is one of these x's equal to? It's equal to 8. Now, you don't have to write the 1. In fact, I'm going to use it as part of a box because I always box the answers. But there you go. And you know that it's the answer for certain. Now, maybe in your imagination, you might have been able to imagine what the answer is, but that's not algebra. Oh, I plugged it in and it worked. Yeah, but this is not guess and check. This is using the algebra to demonstrate why the answer is the answer. This right here, all of this is the algebra work. This is your conclusion. So if you want full credit, you have to show the method work. Sometimes if you want credit at all. All right, so you're going to do inverse operations to get 1x all by itself, and then it tells you what the thing is. Okay, so now number 2. This one's kind of busy. 2x minus 5 plus 7 equals negative 10x plus 8 minus 6x. Oh no, it's complicated. Yes, but we'll make it simpler. Before we begin moving things around to other sides of the equation, I need to simplify. So I'm gonna take a look here. Where's my equal sign? Here it is. Look to the right. Oh, I got a variable right there and another one over there. And then look to the left. Oh, I only got one variable there. But I can simplify what's on the left-hand side, and I can also simplify what's on the right-hand side first. So before you transform things across the equation sign, simplify first. Now you simplify by combining like terms. Like terms are terms that have the same variable. And what you do is you combine the coefficients. So I'm just going to start at the beginning. Do I have any other x's on this side of equals? No. So let me drop my equal sign in there. And I'm just going to copy down 2x. See, I'm done with that. Now, these are like terms. Negative 5, positive 7. Those can be combined into one term. So if the signs are different, you find the difference. What's the difference between negative 5 and positive 7? That would be a positive 2. Make sure you have a sign with it. You can't just write 2. So now I've simplified the left-hand side. Let me simplify the right-hand side. Oh, look, I have like terms over there. Negative 10x minus 6 more x. If I have negative 10 of something, and then I have negative 6 more of the something, what have I got? I've got a negative 16x. When the signs are the same, you add the numbers, and then you keep the common sign. We're making a distinction here between the signs and the numbers. Those are two different things. So now that I've used those two terms, I'm going to mark those through. And then the only thing left on the right, the only thing remaining on the right is plus 8. Okay, now when I look at it, both of those sides have been simplified. Now I need to decide to get all of my x's on one side of equals. I like to do stuff over on the left-hand side. I like to have my x on the left-hand side. So I'm going to move this negative 16 to the other side. How do I undo subtract 16? Because that's what that is. I would add 16. So I'm going to add 16x, not just 16, 16x to the left. And I'm going to add 16x to the right. I'm going to drop my equal sign straight down. This cancels. That's 0. All that I have remaining on the right is just 8. But now I can combine these two like terms. That's why I wrote the 16x underneath the 2x. They're gonna go together. So what is a positive 2x plus 16 more x? That would be 18x. And then the 2 comes down here, plus 2. So now here's my equivalent equation. And now it's very similar to the first one that we had. The first one we had two terms on the left and something on the right. And what you had to do was then transform it around. So what is simpler, adding 2 or multiplying by 18? Hopefully you see that adding 2 is simpler. How do I reverse that? I'm going to subtract 2 from both sides, minus 2 from this side. Drop your equal sign straight down. On the right-hand side, 8 minus 2, that's just 6. On the left-hand side, these cancel. That's the whole purpose of doing that. And then I'm going to have 18x. And a lot of kids at this point would stop and they would use their imagination and they would say, 3, Mr. Marsh, that's the answer. No, don't trust your feelings. Trust the math. And they say, but Mr. Marsh, 6 times 3 is 18. Yes, but that's not what's going on here. Don't abandon the algebra. How do I undo multiply by 18. Well, you divide both sides by 18. Divide this by 18 and divide that by 18. And now this cancels. And now do you see, can you see what that's going to be? That's not 3, although there's a 3 involved. X is equal to, can you reduce those? Both of those are divisible by something. What are they divisible by? 3, right? No, 2. What is it? What's the greatest common factor between 6 and 18? Oh, it's got to be 2. So what's 6 divided by 2? 3. And then 18 divided by 2? 9. Oh, wait, I could have done more. I could have gone for 6 directly. But you can do it in 2 steps if you want to. 9. Divide both of these by 3. Well, what's 3 divided by 3? That's going to be 1, and that's going to be 3. Final answer is 1/3. Yes, there's a 3 involved. But it's not 3. That would be 3 over 1. It's 1/3. And yes, you should give your answer as a perfect fraction. You should not be doing 0.3. That's actually not the same thing. That's 3/10, not 3/9. Remember we had 3/9? Don't even say 0.3333 repeating. 0.3 bar. That's not very good either. Just give it as a fraction. You shouldn't be afraid of the fractions. Okay? So what we did here is we collected like terms first. Then I had to get my variables all on one side. So I moved the 16x to the left. Now it tells me that x is 1/3. I don't know that I could have gone back and looked at that and used my imagination to get 1/3. See, this is the power of the algebra. You don't have to imagine what it might be. You use the process and it will tell you exactly, with certainty, what the answer is. Okay, one more. Number 3. 2 minus 5 and then parenthesis n minus 2 is equal to 10 minus 4n. Now, be careful, because one of the most outrageous and yet common algebra mistakes is to simply work the mathematics from left to right. It's 1/4 past the hour. And so students want to say, don't write this down because this is wrong. Students want to say, oh, 2 minus 5, that's -3, and then parenthesis n minus 2. No, stop. 5 here is being multiplied. 2 is subtracting. 2 minus 5 times. Which one do you have to do first according to order of operations? You have to do multiply before you can subtract. So no, you don't go from left to right. You have to multiply -5 into that group. So I'm going to take -5 and I'm going to distribute it into this term and also into that term. It's called the distributive property. You've probably seen that before. So the 2 just carries along. 2. Now, be careful here. You're going to have to be thoughtful about details. What is a -5 times a positive n? That's going to be a -5 times n. That's not too hard, but the next one is also where kids mess up. What is a -5 times a -2? And if you don't know that automatically, do them in 2 little steps. What is the negative times the negative? That's a positive. Ta-da! Not plus or minus, it's a positive. Only one sign, please. Now do the number. 5 times 2, 10. So I'm saying a -5 times a -2 is a positive 10. There we go. That's called distributing the negative. If you've been in my class, I have a rubber stamp that says that because kids don't do it a lot. But you've got to distribute that negative with the 5 into the -2. All right, so now I'm going to just copy down what's on the right. 10 minus 4n. Now I'm going to take a look. Okay, I've done the simplification there, but on the left-hand side, I have like terms that I can combine. I can combine a 2 plus a 10. That's going to be 12. And then the 5n doesn't combine, so that's minus 5n. That's going to equal 10 minus 4n. There we go. Now I can't simplify either side. I'm going to have to move my n variable to the left. And you can move it to the right. You can take that -5n and move it over there to the right that you want. It's all the same. You just have to keep track of it. So I'm going to reverse this by, instead of subtracting 4n, I'm going to add 4n to the left. Drop my, whoops, not there. I'm going to add 4n to the right. And remember, you have to be right and left of 0. Put a dashed line there if you need to keep track of which sides you got. So then plus 4n. And then on the right-hand side, that cancels. All I'm left with is 10. And then this is going to be 12 just minus n. Okay, getting simpler. Now I'm down to one variable. I need to move the 12 to the other side. How do you do that? Well, it's actually a positive 12. I could very easily turn those two terms around and say negative n plus 12. That's the same thing. But I can handle it here in the order that it's given me. How do I undo add 12? That would be subtract 12 from the left, minus 12 from the right. This cancels. Bring my equal sign straight down. 10 minus 12, negative 2. But be careful here. The negative goes with the n. You don't have n remaining yet. You have negative n. So what does this mean? This means the negative of a number is negative 2. So what's the number? You can probably tell by instinct that it's positive 2, but let me prove to you that it's positive 2. I need to change the sign on n. What's the number, Mr. Marsh? Well, it's just a 1. It's just a negative 1. So if I multiply the left by negative 1, and I multiply the right side by negative 1, notice I put parentheses around that second negative 1. Otherwise, it would look like subtraction. If I didn't put parentheses there, it looks like minus 1, but that's the wrong operation. It's multiply. A negative times a negative is a positive. So good. That becomes positive n, and this becomes now positive 2. There you go. Anytime you want to change the sign of everything in an equation, all the positives become negatives, all the negatives become positive of all the terms, just multiply or divide through by a negative 1, and that'll do it for you. Okay, that's like a major crash course in solving equations. I tried to pick 3 that had all different kinds of things I wanted to talk about. Thank you for sticking around. It's going to be 17 minutes. Ta-ta for now.